All right, so for Unit 6, Lesson 2, we're going to get more into proofs. Now, we did proofs a little while ago, but we're going to get more into different kinds of proofs, and we're going to get into algebraic proofs and a little bit of geometry proofs today. So first off, I want to do is review reflexive, symmetric, and transitive property. So with reflexive property, that's, like I said, looking in a mirror, you're looking at reflection, you're looking at yourself. So A equals A, PQ equals PQ, angle 1 equals angle 1. Same thing on each side. Symmetric is when we can kind of switch the order. So like for this, for all numbers A and B, if A equals B, then I can switch it and say B equals A. Or if AB equals CD, then CD equals AB. You can switch that order. Transitive, I like to think about it like a train. It goes from one to another. So it says like if A equals B, B equals C, then we kind of cut out that middleman and say A equals C. So that's what's cutting, or that's what's going on with transitive. And then we have some standard properties. If we add or subtract, we have those properties. Multiply and divide have their own properties. If we substitute something, that's called substitution property. And then distributing, just if we distribute inside parentheses, that's just the distributive property. So we're going to be using these as our logic and reasoning here. So for example 1, I want to justify each step in solving. So I want to prove whatever x is when I'm solving it. So what I'm going to do is I'm going to separate this into a 2-column proof, and I'm going to have my statements, and then justifications or reasons would go over here. And step 1 is my given. So I'm given 3x plus 5 divided by 2 equals 7. Then I would just go about and solve normally. So what would I do in order to solve this? Well, typically I would times by 2, right? So like off to the side, I can kind of do some work. And I know I would multiply by 2. That would cancel, and multiply by 2 over here and be left with 3x plus 5 equals 14. So that result is our next step. And how did I get that result? Well, I multiplied. So we can just write multiplication. And if you write multiplication property, that's okay, or just multiplication is okay too. Step 3, now what would I do next? So next I would probably subtract 5. I'd be left with 3x equals 9. So that would be my result here. Again, how did I get, equals 9 plus 9. So how did I get that result? How did I get 3x equals 9? Well, I subtracted. So subtraction. Next, I would divide by 3, and I'd be left with x equals 3. So my fourth step, divide by 3, I get x equals 3. And how did I get that? I just divided, so division. And that's it. That's my proof for how x equals 3 here. Next one, again, I'm going to write this out. So statements, justification, step 1 is just what we're given. So first thing here, I'd probably distribute this out. So when I distribute, I'm left with 3x minus 6 equals 12. So what did I do? I just distributed. Step 3, I would probably add the 6, so then I'd be left with 3x equals 12 plus 6 is 18. So that was just addition. And then step 4, I divide by 3 again. If I do 18 divided by 3, that's just going to be 6. So I divided, division. And that's it. I solved for x.